Start streaming. Start streaming. Testing, testing, testing. Ooh. Stinger. What does that do? Oh, okay, that just stings. Hey, I've got a second camera. Okay, am I streaming? Is this even happening? Oh yeah, go in here and then let's live now. Oh, excellent connection. Okay, we are live. Are we live? Are we? Okay. I see the chat. I see the 1, 2. Oh yeah, go in here and then let's live now. Oh, excellent connection. Okay, we are live. Are we live? Yeah, let's fade again to my face camera. Okay, welcome to my. I need to mute the. I'm getting the hang of it. I'm not a boomer. You're a boomer. Okay. Welcome to the morning of coding. Or indeed, if we drop the G's, the morning of coding. Um, and as promised, I'm going to be doing some drawing with processing in Python. I'm going to be using it. I'm going to be using the Turing Lab that I've made just a very simple way of accessing. It's just one link, and then you're in a thing when you can write Python. It's their project for Christmas cards, but doesn't matter. It gives me a 400 by 400 canvas. I'm going to explain that as well. And I want to see, okay, so let's see if I get my OBS right. I'm not going to use, my second camera, I'm going to use it for other stuff. Um, can I remove this? Yes. And then I can cut to this mode, yeah, and then go here. Right, slow mode is on in the chat. Um, Error, oh no, my keyframes. What's happening? Right, anyway, we let's go to turinglab.co.uk and we will find Christmas cards. You don't need even to have an account. You will find Christmas cards in the content. And actually, see, it will have saved, it will kind of still know who you are, and that's probably from last week, I guess. Or is this the thing I was doing last week with the barn? It is, it is. There it is. Look at that. Yeah, that was last week in the morning of coding. It's available in the archive. Well, look at that. I'm just going to take everything and delete it. But that's fine because I've got also a replit link, which you'll find under the video, and it's all there as well. That's my Christmas cards. So if I run this now, there's nothing. White blank canvas. Um, Speaking canvas, yeah. So I can I plan to. What I'm going to be doing today is not a nature scene. That's what I would feel. I don't think it's appropriate to do it in the style of Bob Ross. Um, what I want to be doing today is something in the style of Dutch artist Piet. I actually had to look up a video on how to pronounce it. It's Piet Mondrian. Mondrian. You will recognize you see the lines in the squares and the colors. You'll recognize that, right? Famous abstract artist of the 20th century. Now, have to say, right? I'm not an art person, but pictures do not do justice to pieces of art because they don't capture the texture. And so this looks ideal for algorithmic art, essentially, right? This is quite a good, yeah, there's this one as well. Oh, it's the world. Yeah, so then this style can be kind of used to, and this could be done easily digitally, right? You fit an image and it makes a Mondrian style of thing. So let's break it down. Decomposition. What's a Mondrian painting made of? Well, I'm seeing white background, black lines, thick black lines, horizontal and vertical only, that intersect, sometimes filled with rectangles. The problem is that it's hard to distinguish from between his actual art and the stuff in the style of Piet Mondrian. Well, let's see actually what our neural network machines, from say Night Cafe and DALI. Well, you can of course get DALI. You can get DALI in Night Cafe, but if I ask DALI for look at an image. in the style. Look, I think I've got in my history, I've got a little robot Bob Ross or bot Ross. That's pretty good. I need to work on it. I need to get the better prompts. Yeah, those are pretty. Those are actually more colorful than I think is actual Mondrian work. But okay, decomposition. It's horizontal and vertical thick lines, and then primary colors or black to fill some of the rectangles. Now, processing. Um, I don't think that you can like do like in paint, just kind of fill that area with color. So we're going to be making rectangles, but we're only going to use rect processing reference. I think I must have it. PyProcessing.org reference. So we're going to be using rect for rectangles, and we're going to be use line for lines. That's all I need. I wish I could get crazy with that. And primary colors, nothing more to add. Like, just then it becomes at the, how do you think? So, how do astronomers throw a party? They plan it. It's helpful to plan the drawing. I realize retrospectively that in my previous coding tutorial, I was just kind of going straight into it and sort of improvising, but let's do something a bit more formal. So, you can use a piece of graph paper. By the way, if you want to code along, it might be helpful rather than tile the windows if you put like if you watch this on your phone maybe and then sort of you go the full screen to code. I don't know. Yeah, to plan it, piece of graph paper works. I've been using geogebra.org/calculator, which is an online graphic calculator, which is absolutely brilliant, beloved of my colleagues. Teacher colleagues of the maths department. I'm going to open, I've got one. Oh, I'm not logged in. Oh, I think that's because so it's Office 365 is not the same as Microsoft, weirdly, right? Yeah, here we go. See, I was planning some previous Mondrian. I don't. Let's not. It's not want to be prime. No, actually, yeah, okay. It felt. So we'll start with this 400 by 400 template, which is it's helpful because it's already zoomed out and I've got the boundaries, the borders of the canvas, and I'm going to save it as something else. Uh, Mondrian Live for the code. Now, this, yeah, you need to explore a little bit how it works. So if this is the algebra of it, this is really the coordinates and so on, and you can have algebraic curves, y equals x, whatever. So, but beyond the maths code, to use it as a drawing, a sort of mm, sketching tool, I'm mainly going to be using in that instance. It's a little bit down, right? We're not even doing geometrical construction. It's just like segment and line. Segment and polygon. We can even do regular polygon if we want to make sure those are squares. So let's throw a first square in. I think I'm going to build it from the square upwards. So there's like one big colored square, a smaller colored square, maybe a black rectangle. Yeah. And then I want the lines that connect them all, but I don't want all lines everywhere. You'll see what I mean. So let's throw a big square on it. In GeoGebra, to do a regular polygon, you select you make one edge of the polygon. I don't want it to be too kind of like on the grid. So I'm going to go here, wherever that is. So that's like 350, 360. And then, so yeah, make one edge and then say um, how many sides you want. So that, boom, that's a square. And I think I can then move, no, sorry, I'm in square mode. So it will it will work out. Can I undo here? So then I need to go back to move, which is super far, which is annoying. But if I move this, but no, if I want to make it bigger, I move this one because that's the one I constructed initially. You can also change the orientation. We are going to do that because we nice everything is horizontal and vertical on a grid. Yeah, that's kind of a good first square. Too big a square? We'll see. Second square, different color. Very exciting. Is it going to be lined up? But having them like that is a little bit, I want to say, kind of on the nose. I could have it here. Like I'm gonna make a 100 pixel by 100 pixel square. Or maybe completely off the grid. That's another option. Well, let's make it, and then we can always tweak it later. So if I want 100, it's here, and then 4 sides, please. But I didn't want it like that. I want it, nope, not that. Yeah, undo, change to move, and then move this around. Yeah. So moving the second point will change the orientation and the size of the polygon. Moving the first point will change its location, which is helpful when, especially since our rectangle in processing is known by its top left corner. So this is, oh no, it doesn't do that. Okay, so I need to move both. Let's have H over there, and let's have I over here. What if I had this, but then I shift this first one a little bit down. Maybe at all the way down, actually. So at 400 on the edge and inside by 40x. As I do this, I can see the coordinates of my points here, right? Like it's 42. I can even probably change them, right? So that's going to be like 40x, and it's in the negatives, right? Because in processing we are counting down, but it's minus 400. Yeah. What about E? So it's like that would be 210. I'm being a perfectionist here. I could zoom in and snap them or whatever, but 210 minus 400. But I'm more interested in G because that's the top left corner, right? Ooh, minus 400. Uh-oh. Yeah, or y-axis in GeoGebra coordinates is going to be inverted. That's what we need to do. Yes. Okay, G. Oh, G is not been explicitly defined, so I don't have a, fair enough. We can work it out anyway. That's the point of having it. What's happening here? That's my thing. Okay, those are my starting square, and then I'll fill one of the rectangles that is formed in black. Now I need different tool. Okay, so we're gonna have to scroll even more now. Right. As tiny as I can make it while still having free. Yes, segment. Oh, a line, I suppose, if you want, right? Yeah, line is good because it's going to do both sides. So I've got G, I've got F, boom, a line, right? I've got E, I've got F, a line, um, line here, line there, line everywhere. Now, mm, yeah, this one's a little bit upset. Yeah, sometimes there's like a frame of black. Um, there is a hilarious story. This particular one, right, had been hanging upside down for 75 years. Uh, yeah, that's modern art for you. It's abstract art. And we had viewers. We had one viewer briefly at some point. Okay. Uh, I'm in GeoGebra, Mondrian Live. I have done the line, so that's giving me kind of a nice grid based on the square. Right, I'm connecting the corners of the square with horizontal vertical lines across the canvas. Let's use a segment here. I could have used a line. I like that this one, so for instance, I don't want the line between I and J. That would be good. And mm, let's do that for now, and then I will make sure that this I'll draw actually a rectangle over it, so I know which is going to be the black one. And it's going to be maybe even those two. Maybe I'll have like some beyond the colored square. Maybe I'll have like one of the rectangles in yellow, and so that means I need to build it as well. Oh, P is a little bit not in the right place. Good. Okay, that's my planning my painting. Right. Well, let's do it. Right. The background's already white, but just in case I want to change it later. Uh, no, surely. Hold on. If I do this, processing should accept one value. Yeah, and because if I only put one number, it means in grayscale. It means between 0 and 255. Yeah, actually, that means I can make it just like not completely full white. And then Okay. Red, red square. Let's start with like pure primary colors. So that's pure red. I don't even need a 255. 2550 rect. And we had then found out. No, I'm still alive. Okay, it's just an error, right? We find out that was G. So how do I? Well, I can like just explicitly pick G, right? Oh, that didn't do anything. Algebra, C, D, E, and then polygons are defined by that. So then you can line GF. So it knows about G, but it doesn't give me the coordinates explicitly. Mm, I should have. Well, okay, so now I've learned that I should draw my regular polygons from the top left, or the top certainly, so that I have got both the top points, including the top left corner. This point G is at 40 in, 40x, and 200, and each of the small squares are like are 10, right? So 230. The best time to have a dentist appointment. 40, 230, and it is. Mm-mm. Okay, how tall it is? Well, it's between 230 and the bottom, right? The bottom being at 400, that makes it 170. Boom. Now, this is what's good is because I'm going to be using the same. Let's again have a look at this example. You notice like it's just one line, and it's quite a thick one, right? So I of course needs to be my stroke is going to be valid. It's going to be black. Stroke is 0. That means the color 0, right? And stroke weight, which is the thickness. Let's start the bidding at 5. I like that. Right. Cool. Now, blue square. I'll I can tweak the colors later, but I will, um, I will start them with like just primary 0. No, because red 0. Fill should be 0 red, 0 green, 255 blue, and it's a rect that's located at. It's this one, and I is at 250, 50, very nice. 250, 50, and it is 100, 100. This one is easier. 250, 50, 100, 100, 100. Get red square, blue square. And now in terms of the lines, I'm not sure I've super paid attention as to exactly which one I've drawn and not drawn. Where I've used the GeoGebra line tool, which draws like a Euclidean line, which is infinite, I will simply use the processing line function, which leaves the lines in between 2 points, but using points on the border. So one of the coordinates is always going to be 0, 400. By that I mean, so the first one I drew, let's do it in order. I did a poly. I put H and I. Where are H and I? Yeah, so this is when I did the second H and I. Didn't make the thing. And an I. Segment H, I. Where is it? L. Oh, because the lines have got names. Surely we should start at A. Oh, A is here. So which is A? Line A. I get F as a segment. Can I click on the name? No. Right, whatever. Let's do them in whatever order. Let's start with those. So it's L, which is, yeah, that's 40, 0 to 4400. I'm going to do all the verticals. I'm going to organize it nicely. Vertical lines. So, line 40, 0, 40, 400. It's taking shape. Next vertical line is between 210. It's at 210, right? So it's 210, 0, right? if I was in Replit, I could replace both of those in just in one go. Uh, I can here as well. My God, this is amazing. So this is, I'll show you this trick with the next one. Um, Next line, please. We've done a 210 there's one at 350. So paste it, select the number I want to change in both places, Control D or Apple D. Okay, do I, like, this is where maybe the second camera, but I would need to get back into OBS. Not worth it. And then now that both are selected, I can type something in there. That was, I believe, 350. It changes both places in here. Kudos to the uh, Turing Lab developers that have made a nice little bit of IDE, integrated development environment. Now look at this. Do I only have 3 vertical lines? Any more for the vertical? I may put like lines around the edge. I'll play it by ear. And then horizontal lines, well, again, 50, 150, 230. Now for horizontal lines, this time it is the x that the first one is 0, the last one is always 400 because we're at the edge. Is those second numbers we change, and I had declare 50, yeah, 50, 150, 230. Like that. I'm just putting something so I can up 50, and I put it in the wrong place. It's the y that changes. So it's always at 0. Yeah, the 50 is here. Take this, copy, return, new line, paste, select the 50, Control D, 250. New line, paste, no, 50, 150, 230, no problem. Look at this. I don't think I need the edge, right? Because at the moment, the way it's framed, because it's framed by the IDE and I'm in night mode, the edge is already dark. If I were to change it to light mode, I like that if there's a stop button, it probably means that, I'll see about that. Horizontal lines is, I think, done. Chuk chuk. What are we doing next? And we want this to be blue. So this is a rectangle centered at 40, 50, and it is, ooh. Okay, this is 40. This is 210. 210 minus, surely one of those is a calculator. Yeah, look at that. 210 minus 40. Oh no, I'm in the formula of something. What am I doing? What is I going to do? Oh, abort, undo. I just wanted just a regular calculator, please. Just, I might, yeah. Okay, what's 210 minus 40? Actually, I know it's 170, but for some reason, yeah, it doesn't work in the same way. That's the graph calculator, not a numbers calculator. So it's 170 wide, and it looks like a straight 100, but it looks about 100 tall. And I said, then we want the blue, no, the yellow, yeah, yellow rectangle is a rect. So that's where I'm putting my fill. Needs to be, what's yellow? Yellow is red and green in additive synthesis. And it's a rect that is centered at 40, 40, 50. And it's 170 wide and 100 tall. Yellow rectangle. Very nice. Very nice, very nice, very nice. Actually, I mean, that would probably pop even better. I thought I was going to change the colors, the primary colors. Maybe I will, but I mean, I like it. It really pops. Even more. I don't know. I mean, I could throw a little bit of randomizing and stuff in there, but I want to keep it simple for the kids. Uh, right, and now let's fill some of those in black, I reckon. Um, this is artistic decisions that should be made. I'm thinking this top one. Maybe even, maybe even that whole block. What would that look like? I don't even need to go to GeoGebra right now. Black rectangle. It's the same deal, but with a fill of 0 this time. Again, just pass it one number. It's fine because it's black. Um, and it's at 0. No, 0 is the, it's a rect, obviously. It's X is 40, right? This is, now we're starting to get familiar with the number. This is clearly for 40. We've been using that in a couple of places because there's the corner of that rectangle, the corner of this one, and the first vertical lines. 40, 0, because at the top, to, and I want to go all the way there, and there is, this is where I need it, because that's going to be helpful. There is 350, fair enough. So it's 40 of one side, but 50 of the other. And so it's 350 wide. Nah, okay, it's 350 wide, but it started at 40. So it stops at 350, it started at 40, it's 310 wide, and it is 50 tall. There's a There's a pun to be made with the name, but I can't think of it now. Right, what is left for us to do? We could. Um, hmm, I could stop there as the first tutorial, but then based on that, if you say once we have decomposed the picture, not painting. Actually, there was those were not just painting, right? That's why, like the one that was hanging upside down in particular, it's all kind of like strips of colored tape. This is why the picture doesn't really do it justice. It is kind of bumpy and stuff. And the reason now because it's been hanging upside down for 75 years, it's gotten used to the strain in that direction. And the conservationists, the people, the museum people, will not actually display it the right way around because that might damage the painting. But once we've decomposed how the Mondrian was composed, actually, composition is putting the thing together. Decomposition is looking at the painting and saying, well, how is that made? One square, we've used the red one. One big square, one smaller square, one rectangle. Well, the rectangle comes after because like it's based on the lines we made. So one big square, one smaller square. We need um, the moving part here is like the location of the big square, the location of the smaller square, and their sizes. Um, so if you could randomize the location, start with those. Once you get those, all of the lines are made. You might not connect. You might say not do all of the corresponding lines of the smaller square like I did here, right? But again, that's a procedural rule. Procedural means you can define it as a procedure, as an algorithm. You see where I'm going with that? So what we could do is some code that uses randomness and variables to generate a different Mondrian style piece, art, sketch every time. And that wouldn't be too complicated because everything is driven from the location of the two squares. And then you just have to make some choices as to like where you're going to put the rectangle, like which color, which part of the grid you've defined are you going to color in what colors. But again, you can pick at random, or you can make an interactive sketchbook where like the user clicks where they want the first square, the red square. Let's call it this, and then colors. Obviously, you can play with that, right? Then clicks with the second, and then decides which ones to fill in, and instant Mondrian. But to play with the colors, if the red, if I want it a little bit darker, I've made everything a little bit darker, right? Background at 250, that's maybe too much. 220, 220 as well. And it's just like a hint of grey for the age. Same deal here, although I'm going to want some green here. Yeah, made the colors a bit different. The blue is not that much different. Yellow still very poppy. That's strong, right? So how about 200? Like a faded. I'm not. The lines need to be pure black, although I'd like rectangle could come as a 10 to just be a bit grey. My yellow's too grey now, but we can just like pump some blue in it. It's getting quite sickly now. A bit better, a bit better. So yeah, I want 230 now in the. Oh, yeah, that's an alternative. Oh, what's happened? Yeah. Okay, well, I'm just gonna go to replit.com and create a REPL so you can have access to this code, uh, and so you can check it. I might even check it in the video description, do that live. I want a processing REPL with the Python flavor, and this is going to be called Mondrian. Select everything, copy. I may need to, so the default processing book in Replit comes with some basic stuff to do actually animated sketches, but for a static one, just paste it in. I may need to give it the size though, just so it knows, and that's 400, 400, and I believe that should run. It's going to take forever because processing is like way slow. Um, that was fun. We had some viewer. Hi, Minecraft build hacks. Um, Average view duration 154. This is a win. Okay, is this still not started? Let's see what Stable Diffusion might have to say about Piet. I think composition is effectively what we are doing here because we are taking a thing, but like the painting is like there's more in the physical object that the digital version. It's definitely square. Let's get four of those. Let's overcook the image. Overcook the image means it's going to spit out like the exact training data, which is like a bit of a problem for intellectual property when it comes to machine learning models. But yeah, there we are. Okay, OBS. Let's go to what am I doing? Yeah, I wanted to show you. So I just want to show stable. Look at that. Yeah, and that came out so quickly as well. Those are too colorful though. And in fact, some of the it doesn't do that, but that's cool. That's interesting, right? Because it's like it the limitation of the model means that it actually it puts a creative spin on Mondrian's work. Um, and there's some kind of texture there, as if it was a photograph of a painting. Yeah, not bad. Okay, I think that was half an hour. Is probably enough. Uh, fade. That was no, actually, it's fade to this. Hello. Oh, this is nice. I'm going handheld. Yeah, that was the morning of coding. I did it on this. Look at that, infinite recursion, infinite regress. Ooh, thanks for watching and goodbye. No, God, yeah, it's no here, there.